Welcome back, friends. So now I'm going to work on number 3 that was on that same worksheet. That one said we're going to find the integral of the square root of 5x minus 2 dx. And again, you do see there's an inner function there, so we can't take the antiderivative like we normally would because of that square root and because there's an inner function. But as soon as you see an inner function, folks, you think U-substitution. So let's make that our U, our inner function is 5x minus 2. Therefore, derivative of that, du dx, is just 5. Therefore, dx, we solve for it, is du over 5. Or I'm going to change that just now because I don't like the way that looks. That's the same thing as just 1/5 du. All right, we got our inner function here and here, so I can do a substitution. I've got dx here and here, and I'll do a substitution here. We'll come on back up here. This is going to look like the integral of the square root of, well, u. That's it, because the inner function was 5x minus 2, and that goes there. Dx is way over here, so that becomes 1/5 du. That's actually looking pretty good, folks, because it is all in terms of u, so there's no x's I have to worry about canceling. But I do have that 1/5 there, so again, I can bring that outside the integral. That becomes 1/5 the integral of the square root of u du. And this we can absolutely take the antiderivative. You know what u square root is, so let's do it. All right, let me rewrite that. How about 1/5 the integral of u to the 1/2 power, that's square root, right, du. All right, that becomes 1/5 is staying outside. All right, antiderivative of u to the 1/2. Let's add 1 to the power and divide by it. That becomes 2/3 u to the 3/2. Did you get the plus c? High five. Good job. Let's actually simplify that a little bit more with these fractions. How about 2 over 15 u to the 3/2 plus c. Great. There's your antiderivative. We're almost done. But again, we can't leave u in our answer. We need to substitute it back in. Here comes our final answer, friends. How about 2 over 15? U was 5x minus 2 from over here, right? All right, plug that back in. 5x minus 2 to the 3/2 plus c. And again, we can always check these by taking the derivative. And at least for the first couple that you do, folks, I would highly suggest that. In fact, I'm going to do it. I'm going to do it. I'm going to check my work. So here we go. Let's take the derivative. All right, here's my inner u function for a chain rule. Okay, power rule. Here we go. We have 3/2 times 2 over 15. That becomes, I think, 1 over 5. Keep the 5x minus 2. Subtract 1 from the exponent. And then multiply by the chain. And the chain is the derivative of your u. So that would be just times 5. Do you see what's going to happen? Oh, that's so pretty. And I just get 5x minus 2 to the 1/2. Or, drum roll please, the square root of 5x minus 2, which is what you guys saw at the beginning of the problem. So we checked it, we did it well. Good job. How did that go? All right, can we try number 7 next? Kind of feel free to pause the video anytime if you want to take a break, or try number 7 on your own and then come back here to double check it. Number 7 is the integral of x over the cube root of 2x squared minus 1 dx on the outside. Okay, can't take the antiderivative by traditional means, so I see an inner function here because that's having a cube root around it, so I think 2x squared minus 1 might make a good use substitution. Let's try. Let's take the derivative. And let's solve for dx. All right, everything looks pretty good. We'll substitute these back into the original and see what we get. Okay, up here on top, this becomes the integral of x. Didn't do anything with that, so it stays there. For now, the cube root of 2x squared minus 1 is my u. And then dx, I'm going to substitute back in what I made over here. Du over 4x. Good. That looks really nice. But I still have u's and x's. Do you see that? So let's just simplify a little bit. I have an x here on the bottom, x on top, they cancel. And this 4 off to the side, again, when I see it on the bottom, I'm really thinking this is like multiplying by the number 1/4. So if that's okay with you, in one big step, I'm going to eliminate the x's and then move the 4 as a 1/4 outside the integral. Check this out. Ready? This becomes the 1/4, the integral. There's no more x on top. So I just have 1 over the cube root of u times, well, we moved the 4, right? So I just have du. Now I think that's actually doable to antiderive, and let me show you why. Remember, this is 1 over the cube root, so I can rewrite it as u to the negative 1/3, because it's downstairs is a negative exponent, and it's the 1/3 power because of the cube root. And now that I can totally take the antiderivative of. Ready? Let's do it. Oops. Let's move this downstairs. Can I move it? There we go. All right, let's keep going. This becomes 1/4. All right, u to the negative 1/3. Let's add 1 to the power and divide by the new power. That becomes, how about 3/2 u to the 2/3. Absolutely plus c, because this is still indefinite integrals. I can simplify my fractions here in front. How about 3/8 u to the 2/3 plus c. And we're almost done. Let's plug the u back in that we did from the U-Substitution. This becomes 3/8. My u from the beginning, let me scroll back up, was 2x squared minus 1 to the 2/3. And don't forget your c. Final answer. You getting the hang of it, folks? It's not too bad. Like you see from the original chain rule that we learned, it's just extra steps you have to think about. But always keep your eyes open when you see these inner functions, because that's a good clue that you're going to use U-substitution. And I love the fact that we can always just check our answers by taking the derivative. I'm not going to do it here, but I would suggest you do it on your own. Maybe pause the video before we go on to the next one and try it. All right, that was number 7. I'm going to go on and try number 9. I love number 9 because it looks like it's going to be a really, really tough one, but it's not. Very, very pretty. This is the integral of x plus 2 times the square root of x squared plus 4x minus 3 dx. Now x plus 2 is actually on the inside. And x squared plus 4x minus 3 is also on the inside. So which one do you choose? Well, I argue with you that I think the square root is more of a function on the outside. It's a better or stronger operation than this literally having just a 1 on the outside of that. So because x plus 2 is just raised to the 1 power, I'm not going to consider him as an inner function. I don't think that's strong enough. So I'm going to actually take the x squared plus 4x minus 3 as my inner function. Alrighty, here we go. Feel free to pause right now, folks, if you want to try this on your own again, and just start up again when you want to see the answer in the steps. There's my u. There's my du dx. And there's that. All right, ready to start subbing in? Let's move over here. This becomes the integral. And now this becomes the square root of just u, because that's my inner function. And dx gets subbed in with du over 2x plus 4. All right, we got du and we got u, but we still have a lot of x's here, folks. Now, the x's don't cancel yet, but do you see something really, really cool about them? Between this and this? Let me see. What if I did this? Now look what actually divides and cancels. So sometimes you have to do a little bit of algebra and a little bit of searching to find the truth. X plus 2, see ya. The 2 on the outside, do you know what that's going to turn into? 1/2 on the outside. You got it. Here we go, folks. How about 1/2 on the outside from the 2 on the denominator? Integral. x plus 2 is gone. This becomes square root of u, or, because I know I'm going to take the antiderivative, I'm just going to write it like that. The 2 is gone, the x plus 2 is gone, and I'm just left with that beauty. Look how easy that is. Ready? Let's do it right away. 1/2. This becomes, how about add 1 to the power, multiply by, there's zip. Don't forget your plus c. Fractions. And final step, make sure you plug the U substitution back in terms of x. We started with x, we always want to end with x. Do you remember what your U substitution was? I think it was x squared plus 4x minus 3. This one is actually a really pretty one to take the derivative to check your answer. So I would suggest it. If you want to do that right now, I'm not going to do it, I'll let you do it, but it works out really, really pretty. All right, I'm going to stop this video. I'm going to do one more extra one that's going to be a trig one, and then I'll go in and do a definite integral when we have numbers. When we have numbers, a couple of rules are going to have to change, but it's going to be a little bit easier because it's going to deal with numbers instead of just variables for the most part. All right, this is the end of video number 2. Let's go on and do 2 more in the next video.